Hello everyone, how are you doing? Welcome to the day 9th of 15 days of React design patterns. In fact, it is more than 15 days of React design patterns now because in the last session, I had introduced a pattern that we didn't plan originally, the optimistic UI pattern, right? I hope you like that video. We all know that in React, the core part of it is the component. Using component, we build our application. Now, inside component, we handle data. How do we handle data? We handle data using state. Once we create state inside component, we have to manage the state. As in, the value of the state will change. As the value of the state changes, it gives the dynamic behavior of your component. Now, most often, the state value changes within the component itself. It means the required logic to maintain the state, to change the state, to keep it up to date confined within the component itself, which is not a bad thing because we know that state is the private data of the component. But more often, when reusability come into picture, or when you have to provide a lot of custom logic to update your state value, you have to think otherwise. You probably need to take out the updation part of your state, the logic part of your state update outside of your component so that you can reuse it in multiple occasions. Also, you can manage it in a much better way and you can reduce the load on your component. So with that, I want to introduce today's pattern, the state reducer pattern, one of the most important React design pattern which make your code much more modular, much more well maintained and structured. But before we get into that, let us take a quick view on what are we going to learn today in this session. First, we will start with what is state and reducer mean in React. Then we're going to talk about the state reducer pattern itself. We're going to talk about why it is more powerful than the regular useState one. We're going to take the real world examples. We're going to code together and build something using the state reducer pattern. Then we're going to do something really magical. We're going to bring state reducer, context provider, and even hook together. When multiple patterns come together, it makes things much more stronger. We're going to see some examples and the code walkthrough with that. Then we'll be talking about, as usual, use cases and ideas, anti-patterns and pitfalls, and at the end, tasks and assignments for you. Excited? In React, state is like component's memory. It remembers things. For example, this emotion. And reducer is just a plain old JavaScript function that decides how state should change based on an action. For example, if this is my reducer, this guy going to provide some functionality. Let's call it as F. Due to that, this particular state may change to something else. So in React, state is like component's memory and it remembers things between different renders. We have learned that already, right? React component may render, re-render, but state, value, or something that a component remember within its state between the renders. But a reducer is just a plain old JavaScript function that decides how the state should change based on an action. So this reducer, through its function, can tell state to take an action. Because of that action output, its value might get changed. So that is state and reducer at a very high level. At any point in time, if you have to explain someone about state and reducer, just remember these two analogies. Ideally, within a component, let's imagine this is a component. And let's say that the component has a state. This is the component state. And there is an interaction point somewhere in the component. Maybe this is a button. And someone just click on this particular button. And because of the click of this button, what we do, we might want to trigger certain event, maybe a click event, and then that update the state, right? Within the component, we have seen that. But in terms of reducer, the biggest change over here, this updation of the state may not reside, or I would say should not reside within the component itself. Rather, we will take this updation outside of the component. Now imagine that there is something called reducer somewhere outside of your component residing. And I told before this reducer is nothing but a plain old JavaScript function. That means this reducer is a JavaScript function. Now, whenever there is a button click happen, whenever there is a click event happen, instead of updating the state within the component, what now I am going to do, I am going to do something called dispatching an action. And with dispatching the action, I will call this particular reducer. Now, within the reducer, I will define what kind of changes I want to make to my state. Now, once that state changes happen, the change that I have done based on the action that I have triggered using dispatch, my state change will occur. So, this is the difference. This is in a regular case, using useState within the component, you are updating the state within. But here, the updation logic, if I want to take it out of the component, keep it somewhere else, because I may want to reuse this logic elsewhere. I want to keep this particular component much more lean. I don't want to put the logic inside the component itself. I want to keep it outside. Or having the updation logic within the component, it feels hard coded. If I am able to take it out, I might want to give different kind of implementation to update my state. All this flexibility that comes to me if I am able to take the updation logic of my state from the component to the outside to something called reducer. So this is state, this is the state that still remain within the component. This is the reducer, a function which holds the updation logic of the state, it remain outside of the component. And there is something called a dispatcher action which is responsible to inform reducer about what kind of action happened inside the component, so that based on that kind of action, reducer now can change the state and can update the state for the component. This is what is state reducer thing in React. Okay, I hope you understand. Now what we're going to do, we are going to get into the state reducer pattern. But before that, I want to introduce, you probably already be aware of a hook called useReducer. Let's take a look into that hook, because once we take a look into that hook, it will make much more sense for us to understand state reducer pattern much more quickly. So here goes the hook called useReducer. Let's do an anatomy of useReducer like how we have done for useOptimistic in the last video, right? But this is much more simpler than useOptimistic in my opinion. So useReducer is a hook that you get from React library, which takes two mandatory argument. One is called a reducer, which is a plain old JavaScript function. So this is the reducer, a plain old JavaScript TypeScript function. And the second one is the initial state. I'm sure you have used useState. If you're watching this video, you must have used useState before to manage your state within the component. They are also used to pass an initial value, isn't it? This is that initial value. So initial value. And this useReducer hook returns two things to our component. Okay. The first thing is called a dispatch function. I have showed you in this diagram that from component, I can call the dispatch function to signal our reducer what code change you have to done based on what kind of action, isn't it? So that means my component has to get this dispatch function so that on any kind of interaction inside my component, I can call this dispatch function. That's the whole motive here as well. I get the dispatch function, so a function that my component calls with action to trigger a reducer logic. Okay. Now, once that reducer logic happened, what reducer returns ultimately returns a state. The current state, that's actually the update based on this initial state value. So that's exactly the thing gets returned over here. So this state is nothing but always the current state value. That's all, guys, about this hook. I hope this is clear to you. Now coming to the pattern, the state reducer pattern. Let's put a definition around the pattern. It makes more sense then, right? A state reducer pattern allows components users, a particular React components users, to control and extend how a component manages its state by providing their own logic. The logic stays inside reducer. Complex? Let me break it. The state reducer pattern allows a component's user to control and extend how the component state value should be changed, altered, modified, but providing their own reducer logic, own custom logic. That means from outside of component, now different kind of logic you can supply to change the state value of the same component. Think about the reusability. Before with useState, you used to hard code the state changing logic within the component itself. Now, as you have taken that out of the state and given the power to the consumer of your component to pass the logic of how your state should be changed, it brings more power in the architecture that a particular component state value can be changed in a multiple different ways based on the business logic. Now, this is more flexible and more sensible thing to do. I'll take an example of the same thing. Okay, very easy example, and we're going to code that immediately after this. Let's say we have a toggle function. You know toggle switch on off on off. So we have a toggle function and a toggle component basically. When you click on the component for the first time, from off it become on. Once you click again it become off. When it is in the off mode, let's imagine it's a red color square, off written on top of it. When you click on it, it become on and it turns green. So it's a toggle on off, right? Now if I ask you, buddy, can you write a component like this in React, which is a toggle component? You will write it in no time. What you'll do, you will create a state using useState call on, right, and set on. You will have a button. On click on the button, you just toggle the state of it, and based on that, you will show the on and off and show the green and red color on top of it. Very good. Your toggle functionality is done. It will work like charm. But now, if I tell I want a component where you should not allow more than 3 toggles. After 3 toggles, you should not allow any toggle. But I still want a component with the usual on and off all the time toggle. What will you do? You will end up creating another toggle component to satisfy my requirement that you should not allow more than 3 toggles. So now you have 2 components. One is with usual default toggle, another with a toggle component that allows maximum of 3 toggles. And you have to maintain both of them. But what is the difference between these 2 components? Like which is a default toggle, which is always do on off, and the other one which does maximum 3 toggle. The difference is how you are updating and managing the state. In the default one, you are always updating the state on every click, on off, on off, on off, on off. But the other one, it is on, off, on. After that, no state change. So difference is only in the state change logic. How about I can take out the state change logic itself from the component so that you can have just one component and the state change logic stays somewhere else based on what you need. Your component state changes that way. That's exactly the power of this particular pattern, state reducer pattern. It keeps your component lean. It enables you to extract out your component state logic so that you can have custom implementation of your state change logic to give different kind of behaviors of your same component. Isn't it amazing? Enough talking. Can we get into the code? This toggle functionality itself, can we build first with the default way and then this custom way? Let's do that. Here I have got a React project setup done, and I'm calling it as state reducer pattern project. Under SRC, we are going to create a components folder, and here let's create our toggle component we were talking about, toggle.jsx. So let's start with export default function toggle. Let's write the JSX of it. We want to have just a button, and on click of the button we will handle the toggle with on and off. So a button like this, on click handle toggle. Assume that we'll have a state for on and off. If it is on, we'll just say it on. If it is off, we'll just say it off. Very well. Now handle toggle, it will be a simple function over here. So function handle toggle, we will write the logic for toggling it. Okay, the logic for toggling it is something that we don't want to keep inside this toggle component. We want to keep it in the reducer. So we have to create something called as reducer. Under SRC, let's create a new folder called reducers. Here we are talking about toggle reducer. So let's say toggle hyphen reducer .js file, because this is a plain old JavaScript or the TypeScript file. That's what we said. Now let's create a reducer. First, the reducer is a function. Let's give it a name called toggle reducer, and it takes 2 things. One is called state and second one is called action. Okay, and then inside this reducer we define if action is this, then my state value will be this. If the action is that, then the state value will be that. This is the structure of it. We'll come back to this. While reducer stays over here, the state of the component still remain inside the state itself. Okay, there is no change in that. So the state of the toggle function, which is nothing but on off, right, that will remain inside the toggle function itself. But instead of creating it using useState, we'll be now handling it using useReducer, because that gives us the power of not only initializing the state but also integrate the state change logic with the reducer itself. So for that purpose, let us first import useReducer, And using useReducer, we are going to define two things. One, we will have something called a reducer. How it will come, we'll see, and a state value. A state value, let's assume that for this toggle, we will have two things. One is whether the state is on or off. We will initialize with false, means it is off, and how many times I am clicking on this particular on off thing. Let's have a count of that. So for that, I will have another object inside my state is called clicks and initializing with 0. So these are the two things that I have as my state, which is nothing but an object. Now what it returns is going to return to my component the current state value and a dispatch function. That's what we have learned, using which I can dispatch an action to my reducer, and inside the reducer I have the logic anyways. So far we are there. Now where is this reducer and where is this reducer come from? Let's imagine that we are passing this reducer as a prop while using this toggle component. So let's imagine that for now, and this gives me the state and the dispatch. So far so good. Now what we are going to dispatch? So as you understand, we will be now calling this dispatch function on the click of this button in the handle toggle function, and this dispatch function will alert my reducer with the action that I will be dispatching with. Okay, this is how it is. So it means it will be something like this. I'll be calling the dispatch function over here, and I'll be saying that my action is type of the action that I am going to perform now is nothing but a toggle. Fair enough. So I am now calling the dispatch function with an action whose type is toggle. This particular action now will be available inside my reducer function. This reducer function I have started writing over here, toggle reducer. Okay, so toggle reducer, let's do an export of toggle reducer from here. Let's import the toggle reducer over here, and we can actually use it as a default value of the reducer. So it means if there is no reducer passed from outside while using this toggle component, I am defaulting the reducer for this component as at the toggle reducer. So this toggle reducer itself comes over here as a reducer. So that means if I dispatch from my component, this toggle reducer will get an action which I already have, whose value will be exactly this one. That means action will have a type, and the type's value is toggle. Correct? So now I can go to my toggle reducer, and I told that action will have that type whose value will be toggle. I can now do a switch case on action dot type, and when the case is toggle, that time I can change this particular state value, saying that on whatever the state on value was, it will just be opposite of that. If it was false, it will be true. If it was true, it will be false. And we have another thing called clicks. The value of clicks will be whatever the current value of clicks plus plus. Every time toggle, I just want to increase the clicks value. So this is my state value, state change value. Let's have a default case for the switch, which is always a good practice. There we are going to return the actual, the original state itself, and this must be a string. Okay, so I have this toggle reducer function complete. This toggle reducer function I have already imported, I have already used over here. So that means initially this toggle reducer has got this value in its state. Initially the toggle reducer got this value when a dispatch function was called as part of this action. Now I'm checking if actions type is toggle, because this action has a property called type whose value can be toggle. If that is the case, I am returning a brand new state over here. That means the state value was on, and from on I am just making it reverse, on off, and making the click count increased by 1. So this is the thing. If the action type is not matching whatever the state value I'm getting, that only I'm returning. Fair enough. So now I'm getting a state over here. The moment dispatch gets called, this action gets executed, I get an updated state. If I get an updated state, I can very well destructure on and clicks from the state, because these are the two things now I'm going to use in my JSX. Okay, here as you see I'm already using if on is true, show on, if on is false, show off. Along with this I can also show the clicks value, like how many times I'm clicking. And I can also add a class that will show a green and red color background based on value is true or false. If on value is true, it will show background green, otherwise background red. Okay, we're all good with our toggle function. The logic for toggling on and off, we have now taken out into a reducer and we're handling it using the reducer. Let's go ahead and see how we can use this toggle component. So we'll go to app.jsx. Inside app.jsx, I have imported this toggle and I'm just using this toggle over here. Very simple. Now here is the UI. By default, it is in off condition, click is 0. That's how our state was initialized. If I click on it, it will turn to on, click is 1. If I click on it, again, click to turn to off. I keep clicking and keep toggling and the click count gets increased. You see that? So it is working as expected. Our first toggle is working as expected using reducer. Now this is the same thing we could have done with useState also. Why we wanted reducer? One of the thing that we spoke that we wanted this reducer because we might want certain custom logic for handling the state of the same component. Let's take the same example that we have given. Like this on off toggle happen, but after 3 clicks the toggling should stop. If I have to code that inside this very component, toggle component using useState, either I have to do lot of logic, like in what condition I am using this particular component, or I have to maintain two different component, one for regular toggling, another for click restricted toggling. Like after 3 click, the toggle should be restricted. But instead of going through all this pain, now I can completely handle it using the reducer itself. How? I already have a reducer like this toggle reducer. There are a couple of ways I can do it. Let me show you one way. So I already have a toggle reducer. Let's take one more reducer called custom toggle reducer. This is how the custom toggle reducer looks like. Same thing, just like before, it takes state and action, state and action. Same, just like before, have a switch case, checking for the case called toggle, case called toggle. But here, look at the logic. I'm saying that if state click count is greater than equals to 3, then you return the state. You don't update it anymore. But if that is not the case, then only you update just like before. That's the only change that I have made. But where I have made the change? I have not made the change inside my component logic. I have created a separate function because a different use case. For that use case, I have a different function written and I have exported from here. Now in the app.jsx file, if I have to implement this functionality than the default functionality, by the way, if you notice, I am not passing any reducer over here. Why? Because the power of default parameter. I am actually making it default. If no reducer is passed as a prop, it should be a default toggle reducer. But now I need to customize it. So for customization's sake, let me just copy toggle once more, another instance of the same component, and take reducer as a props because it takes reducer as a props. And over here, I am going to now import my custom toggle reducer that I have created, and I'm going to pass this custom toggle reducer. That's the only thing I'm going to do. No changes inside your component at all. Your component is not at all aware what is going on outside. How my state is going to change, it is up to the consumer. Before, I had to hard code inside the component, and every time I have to change the component logic or some props passing, some circus I had to do. Now no circus. It is decoupled. The logic is decoupled. Outside is the consumer. Whatever way they want to see the state change, based on their use case, they can pass. Now we have two use cases, one default, another with a special use case. After 3 click, it should stop. Let's go ahead and see the output. As usual, both are initialized with off and 0. I click on it like before, it is happening toggling. And this custom solution, first time toggle, second time toggle, third time toggle. Now I'll keep clicking. I'm actually clicking, nothing happening on the click. Okay, but this one keep happening. So same component, completely two different use case, two different implementation without changing this component code is possible using the state reducer pattern. Guys, liking it? If so, please like this video, post a comment below. It will be a lot, and please subscribe. Awesome. So as this is done, now the next thing we are going to do is this. We have learned that context and provider shares the data globally, basically shares the state globally. And we have also learned now state reducer pattern lets you control how this shared state can change, right? Because it works with the state change, and context works for making the state global. So if we can bring all this thing together, context and provider will work for a global state, state and reducer will work on changing that state by using state reducer pattern just now we have learned. The diagram that you're seeing on the screen is trying to depict that. This one, the inside one, is a component. Let's write it over here with so that there is no confusion. It's a component. And this dot around that component is nothing but, I think you guessed it, a provider, which provides certain value from the context. This C is the context. We know this. I have taught this as a separate session earlier. In this session, we have learned something called state reducer pattern, through which you can control the state changes with the logic that is kept outside of the context of that particular state, means the component. In this case, this value is global, not inside the component, but still you can apply the state reducer pattern to it. It means that you can keep the reducer somewhere, and whenever there is an interaction occurs inside the component, it can still do a dispatch of an action. This action can go to the reducer with the initial state value and then ultimately update this value over here, and that's the value goes inside the component. So before, this value was inside the component as a state, the same diagram we had, if you remember over here, exactly the same diagram. The state was inside, and from an interaction point like a button, we dispatch an action, it went to reducer update the state, return the new state got updated. Exactly same thing happening now for a value which is inside the context but not inside the particular component. So this is how you can think through the architecture at the higher level. Like whenever you are bringing certain things, you can bring elegance also. Like when you are working with context provider, you can still apply the state reducer pattern to ensure that the same philosophy that we have seen, like for the same context value, right? You don't have to now create different context if you want the value to be modified based on your use case by the different logic of reducer. That's the exactly same thing we have seen for toggle. The same thing can be applied in the context of a context as well. Can we walk through a code and try to understand that? Imagine we have a form and there are a bunch of form fields exist. Okay. The form fields, this is validation. For example, there is an email field, and you cannot have an email without the at, right? There is a name field, you cannot have number inside the name, that kind of validations you have. So for that purpose, I have a component called form field. Okay, so this is the form field component, form fields component. Now this form fields component having two input field, one is a name, another is the email, and both the input fields are having a on change method which is nothing but handle change. If I go to handle change, just like before the handle click, handle toggle, we used to dispatch something, right? We used to dispatch an action. It is dispatching an action saying that change field. If you see here, it is dispatching an action called change field. Along with the type of the action, the dispatch in this case also pass something called a payload. Payload is an extra bit of data that you can pass to your reducer while dispatching an action. Taking that payload, a reducer can use that payload to further update the state in a way that you would like to. So in this case, we are now dispatching an action to a reducer. You know now very well that I'm using a reducer over there, right? A reducer, and that reducer will not only get this action type, it will also get this payload so that it can use it. Excellent. Now let's go up. Here, the twist. I don't see any reducer being passed over here. Correct? I don't see any reducer being passed over here. Now remember the diagram that I have showed you some time back. I was not passing any reducer to the component at all, because now component is surrounded by what? A provider. So that means if I can pass the reducer to the provider, and we know what provider does, right? Provider actually wrap a part of a component hierarchy or the complete component hierarchy inside which it has to provide the value from the context. We have learned that. So if I can pass the reducer to the provider, or if I can give the reducer to the provider, some way that reducer will be available for the entire context which provider has wrapped, entire component hierarchy, right? So you are not seeing it over because that reducer probably used somewhere in the provider side. Okay, we'll go to that. But let us first see the reducer, the kind of reducers that we have written, because that's an independent logic. Remember, our reducer takes action and the state. Inside action, we have type, and we are also passing the payload. So for that, inside reducers, I have created something called a form reducer. All this code are there on my GitHub, and the link to that is in the description of this video. You can go ahead and check that. So I have created a default reducer. Usual state and action is what it takes. If the action is change field, because that's what we were dispatching, in that case, I'm taking the name and value. I'm checking if the name is email, means it is an email field. If the value doesn't include an at, make the error as invalid email. Okay. and then I am returning the current state value and the error value. Very simple, very simple thing that I am doing. Okay, and if you have noticed here, I can actually take the payload, not only the type, I am able to get the action.payload through which I am getting that the value of the name field and the actual input field name, right? Both the things I am getting over here. So this is my default reducer. Now you understood from the component till the reducer, but one difference than the last time and now. Last time I had passed the reducer itself as a props to my component so that from outside I could control it, but now I have not passed because I am controlling at the provider level. And why I am controlling in the provider level, I have already explained. So let's go to my context and provider. Simple. Context, I have created a context, simple context called form context using React's create context, and I am exporting from here so that I can use it elsewhere. Very simple, no rocket science. And then I have a hook created called use form context so that everywhere I don't have to import use context, form context, take the value from the context and return it. I have just created a hook. This is the pattern I have showed you already in one of the session, right? The hook, context and the provider pattern together. So you know that there is a hook to get the value from the context. So this is the hook. Main thing is the provider. Let's go ahead and see that. See what is happening in the provider. In provider, I am passing the reducer just like how I was doing it in the component directly before. But now my architecture has changed because I'm dealing with the context and provider is the one that wraps my component or the component hierarchy. So if provider is handling a value from a context that it is passing to a component hierarchy, to change the context value, I need the reducer. So the reducer also has to be the provider level only, not in the individual component level. So if you are doing something like you are dealing with the reducer in the component level, whereas you have to change the value of the context, you are introducing an anti-pattern. The right pattern would be you should handle the reducer at the provider level. You have to pass the reducer to the provider if that particular reducer is controlling the value that is there in your context. Okay, this is how the pattern should be thought about. Now this provider takes the reducer just like before. Okay, and of course it takes the children. This is not a rocket science. From the last time we have learned, as we have a reducer, I can use the use reducer hook to get the current state value, get the dispatch, and of course initialize as usual my state value using the values and the errors. These are the things we have modified in our reducer, if you have noticed. Okay, and then the state and dispatch is what as a value I am passing in my context. Okay, very easy, very easy, simple. Now wherever I'm using this provider, for example app.jsx file, if I'm using this provider and not passing any reducer over here, it is going to take the default reducer. Default reducer is only checking for the email value, correct? So my email validation and all this thing will take place, everything will occur correctly. Now say I want one more validation, and this validation I want apart from my email value, I also want to check the name value should not contain any number, and I don't want to mix this validation inside my default validation. So now is the time that I can go to my reducer. I had a default reducer. I can write one custom reducer just like before. And here I write some extra logic, the custom logic to restrict the name to the letters only, along with the previous logic for email. But this time I had made, instead of at, I want to check it has .com only. That kind of validation. So it's a completely different validation. Now, if I want to put this use case, this particular guard for the value in my context, instead of passing the default provider, I will now just pass my custom form reduce. Now, instead of passing the default reducer, I will now just pass the custom reducer. That's all. So this custom reducer will go inside this form provider. It will get the reducer. That reducer will come into picture, and then everything will be stitched accordingly. So I have not really done much than the last time, the toggle one. It's just that it is gone one level higher at the provider level. This is where you are seeing now context provider, state reducer, and even hook for getting the context value elsewhere is working like charm, right? So if I go to the form field once more, you can see from use form context, which gives me the context value. In the context, which value is there? The value that provider provides. What value provider was providing? State and dispatch. The state and dispatch I get inside my component, and that's what I use to trigger the reducer and the state to show the messages, show the error, etc. Right? So this is how everything is staged. Code is there, code is committed, is there in my repository, and the link is in the description of this video. Please take a look at it. And don't forget to do the task, because the task will make you real professional. So where do you use this pattern? Basically, anywhere you can use this pattern, wherever you want a predictable state value transition and flexible customizable points. What is a flexible customization point? Is your reducer. What is a predictable state transition? Is your dispatch based on an action. Because based on an action only you are changing the state. So it is very predictable, like why you are changing the state, right? So there are various use cases we have. We have seen two. One is like toggle. We have seen the form validation. There is another use case that I have given you as a task is about the wizard. We are going to discuss that in a while. Then there are variety of things like, you can do undo, redo kind of operation on your editor. You want to have a state machine kind of control on the UI. Basically anywhere where you want to isolate the state changing logic outside, and you have variety of use cases through which you can change the state but keeping the same component. If you have that requirement, state reducer pattern is what you should opt for. Talk about certain pitfalls or the anti-pattern. If you're using the state reducer pattern along with provider and context, make sure the reducer you keep at the provider level, not on the individual component level. The exact same thing we have seen a while back. Then don't confuse useReducer with Redux. It's similar concept, but the scale is different. Okay. I have a bunch of videos on Redux actually on my channel, so you can take a look into it if you are interested. The second thing would be, I think you will be creating an anti-pattern if you start using this useReducer or the state reducer pattern for a very simple component. A component where the state change logic is very straightforward, like count, right? Or a toggle that is supposed to work only in one way. There are not multiple use cases. Why would you need a complex thing, a little more complex thing like state reducer pattern? You will need it only when your state change use case are multiple. You want to change your state with multiple different logic in different occasion, keeping the component intact, one component, then this pattern. Okay. So these are some of the side effects you have to keep in mind when you're opting this pattern. Otherwise, I think this pattern really works well. One thumb rule that you should always note, that if your components never needs to be customized, don't over engineer it. Bring things only when it is required. Let's quickly look into the task. The task is build a form wizard component. Build a form wizard component using state reducer pattern. All right, the wizard should have multiple steps. Next, previous reset. Now, an internal reducer manages state transition, like what will be from one state to another state, and allow a parent component to provide a custom reducer that will prevent skipping incomplete step. For example, first step, you have two input fields. You want to make sure both the input fields are filled, and then only want to go to the next step. This validation should happen as part of your a reducer that you will be passing it, okay, to your component. And then auto save the data on next. Whenever you're clicking on the next button, whatever the data that you have entered in your previous step should be saved somewhere. You can save it on the local storage or in memory object. Along with that, as you have learned the provider context pattern to use along with state reducer pattern, you can also opt for a global progress bar on your wizard itself. As and when, let's say your wizard has three steps, three screen, next, previous, last is done. As you move from one screen of the wizard to another one, your progress bar shows how much percentage you have completed, right? This progress bar value, how much percentage you have completed from each of this component, that can be done by keeping the progress bar value in the context, because that's a global value, right? So create a progress bar that multiple components can access and integrate with your this state reducer concept that we have spoken about. Little complex problem. If you stuck anywhere, I'm on Discord. Come, the Discord link is in the description of this video. We would like to discuss together and we can build together. Okay, so that's all for today's session. I hope you liked it. In case you liked it, please post a like, post a comment, let me know you liked it, and please subscribe. Up next, we have plenty of things to do, right? We have covered most of the, I would say, basic React patterns. We have also introduced a new one that we didn't promise in the beginning, but we have introduced as a surprise, the optimistic UI pattern. But up next, we have something really good, observer pops up pattern. You don't want to miss that. Then we'll talk about few performance pattern. We're going to talk about slot pattern, going to talk about hook factory, going to talk about facade, then error boundary, and finally the suspense pattern. And who knows, in between there might be other few patterns that come in. And if you think that I have missed any, please request. I might add them as well. Take a great care of yourself. Take care. We'll be back very soon with the next pattern.